Okay, we're now on to probability and sample space tables, and let's get into it. So we looked at this example previously, which said Tommy tosses a fair coin and he rolls a dice. So there you go. Okay, he throws up a coin, rolls a dice, and with the question is saying find the probability that he gets a tails and a four. So you're looking for this specific outcome. He gets a tails and a four. Now, to make this a little bit easier, we can draw a sample space table like we did previously, okay, and we can fill out the table like we did on the previous video. And this just means, again, that you could get a heads and a one, a heads and a two, a heads and a three, or you can get a tails and a one, tails and a two, so on and so forth. And just to remind us, probability is the number of successful outcomes, what you're looking for over the total number of outcomes. So we can say here that the probability, okay, of getting a tails and a four, of getting a t and a four, is equal to, well, you've got one number of successful outcomes is just going to be one. Okay, so one over your total number of outcomes, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You've got 12 outcomes in total. Okay, but a tails and a four, there's only one tails and a four, and there's 12 different outcomes in total. All of these here, you can see there's 12. So the probability is 1/12. And that's it, okay? And this table makes it a little bit easier to see what is going on. And there we go. Perfect. So you can try this one, or you can kind of work through it with me. But let's look at this one. It says 2 6-sided dice are rolled and the scores are added. So you've got dice 1 and dice 2, okay, and then they add the scores together. Complete the sample space diagram part A below. So part A is just saying if you get a 1 and a 1 and you add the scores, it's going to be 2. If you get a 1 and a 2, it's going to be 3. If you get a 1 and a 3, add them together, you get these scores here. Okay, a 2 and a 1, you're going to get a 3, 4. It's just going to keep going up in this sort of linear pattern. 3 and a 1, it's going to be 4, 5, 6, and we keep going. Okay, it's got to go and fit out 4 and a 1. It's going to be a 5 and then 6, 7, 8, 9, and then 10. We keep adding the scores. 6, 7, 8, 9, 10, and then 11. 6 and 1, 7, 8, 9, 10, 11, and then a 12. And then part B is saying, what is the probability of getting a score of 4? So we're looking for the number 4 first of all. So you can see you've got a 4 here. That's 1. You've got 1 over here. That's another one. Are there any more? You've got 1 here. So you've got this sort of diagonal pattern going on. So that's going to be it, isn't it? So to write this formally, we can say, and just give us the probability note, the probability of getting a 4 is going to be equal to, you've got 3 4s there. So 3 out of a total. Okay, this just means a fraction out of a total, and there's going to be 36 outcomes because you've got 6 here and 6 here. 6 times 6 gives you 36. If you count all of these outcomes here, they're going to be out of 36. Now, you could simplify the fraction, but probability is the only topic in GCSE math that you don't need to simplify your fractions. So I'm actually going to leave it simply as this. Well, actually, just in case you might write it, you could also write this by dividing 3 by 3 as 1 over 12. They both mean the same thing, but personally, I would just not simplify it because you don't need to with probability, and that is your answer. Okay, now let's go and look at the next part, which says the probability of getting a score of 5 or less. So of getting a 5 or less than 5, well, let's go through those outcomes. So you could either get a 5 or less, so a 5 and a 4, and you get a 5 and a 4 and a 3, or a 5 and a 4, a 3 and a 2. And hopefully I've missed none out. No, that should be absolutely fine. Ah, one more there. That was lucky. A 5 or less. There we go. Now here, let's go and write this using good mathematical language. So the probability, capital P, of getting less than or equal to 5. If we want to be really nice about how I write this, I could write it as less than or equal to 5. Okay, this means, oh, that's not what I want, sorry. This means, what is going on there? Sorry, right, if I write this, right, that means less than or equal to 5. Okay, you don't lose marks not writing this, but I'm just writing, a good mathematical convention there. And you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You've got 10 outcomes, 10 out of a total of 36. And again, you could simplify the fraction if you wanted to, but I'm not going to because you don't need to. There we go. So that is your answer. Let's go and do it in yellow. Just keep it consistent. Perfect. And then the last part is saying a score of a prime number. Now, just so we don't get confused with all the sort of highlighter parts, I'm going to get rid of this. Otherwise, it will get confusing now. And let's go to those. Bam, bam, bam. There we go. Now, just to kind of really quickly recap, a prime number is a number that has two factors. So, for example, the number 3, why does that keep happening up there? That's really annoying. Right, a 3 is a prime number because it's only got two factors, which are 1 and the number itself, 3. For example, 4, it isn't prime because it's got more than two factors, because you can do 1 times 4 is 4 and 2 times 2 is 4. It's got 3 factors, so that's not prime. Okay, so prime numbers have 2 factors, and those numbers on here, and the prime numbers, they are 2, 3, 5, 7, 11, 13, 17, so on and so forth. Okay, but that's more than enough for this. So we're looking for those numbers. So 2 is prime, 3 is prime, 5 is prime, 7 is prime, 3 is prime, 5 is prime, 7, 5, 7, 5, 7. There's one of making mistakes here. 6, 7 is prime, 11 is prime, 7, 11. Let's just double check here. Right, so 4 isn't, 6 isn't, 4 isn't, 6, 8, 4, 6, 8, 9. 9 has got 3 times 3 as well, so you can't do 9. 6, 8, 9. Good, perfect. Okay, I made no mistakes. That's good. So now I can just go and say the probability, capital P, of getting a prime is going to be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 out of your total number of outcomes, which is 36 in total. And there we go. Okay, there are your answers. So hopefully that was useful, and we're getting now familiar with probability, and we've now looked at it in sample space tables, and we'll be looking on the next video at two-way tables. Okay, thank you for watching.